Have you ever noticed those strong walls holding back soil along highways, gardens, or construction sites? They make soil stay in place on steep slopes or along highways. Those are retaining walls, simple structures with massive strength that quietly do one of the toughest jobs in civil engineering. In this video, we will explain what retaining walls are, their importance in preventing soil erosion and landslides, and the various types used in construction. Welcome to the channel. What exactly is a retaining wall? A retaining wall is a structure built to retain or hold back soil laterally, preventing it from sliding, thereby maintaining different elevations on the two sides. What are the major functions of retaining walls? Retaining walls are used for the following purposes. 1. Earth retention. The main purpose of a retaining wall is to withstand the lateral pressure from the soil behind it. This prevents landslides and soil collapse. 2. Erosion control. A retaining wall holds the ground in place, thereby protecting against erosion. 3. Supporting structure. Retaining walls provide essential lateral support for roads, driveways, bridge abutments, and sidewalks. Types of retaining walls. There are different types of retaining walls, and they are chosen based on the design considerations. 1. Gravity walls. This type of retaining wall resists soil pressure by its own weight. They are typically made from stone or concrete and are often used for shorter walls. 2. Cantilever walls. They are reinforced concrete walls, which typically consist of a stem and a base slab that are critically designed to withstand the soil pressure. They are suitable for walls up to 8 meters. 3. Counterfort walls. They are similar to the cantilever walls, but are designed with extra triangular supports known as counterfort, which are placed on the retained side of the wall, at the back. 4. Buttress walls. The buttress walls are similar to counterfeit walls, except that the triangular support known as buttresses is placed on the exposed side of the wall instead of at the back. 5. Anchored walls. The walls are externally anchored by cables or rods, deep into the soil or rock behind the wall. Let's look into the structural capacity and forces acting on retaining walls. When we talk about the structural capacity of retaining walls, we mean the wall's ability to securely withstand the pressure of soil, or other retained materials, and resist all acting forces without failure. A proper design is about force equilibrium. The major forces acting on a retaining wall are: 1. The lateral and active earth pressure. This is the horizontal force which the retained soil or backfill exerts on the back of the wall. It is the primary force that the wall must counteract. It is calculated by soil mechanics principles like Rankin's or Coulomb's theory. Now, soil doesn't just push on the wall, it also resists movement. This resistance is known as the passive earth pressure. The passive earth pressure acts in the opposite direction to the lateral earth pressure, helping to stabilize the wall, and is caused by the soil in front of the toe of the retaining wall. The passive earth pressure creates a stabilizing moment but is most times overlooked in calculations, as it is not as reliable as other forces, since it depends a lot on the soil in front of the walls. 2. Surcharge loads. The surcharge loads are the additional vertical loads applied to the retained soil. These go beyond the natural weight of the soil itself and may include traffic, structures, stored materials, such as heavy objects, and even sloping backfill. All these loads act as a surcharge and, in turn, increase the lateral earth pressure. 3. Hydrostatic pressure. This is the pressure exerted by accumulated water behind the walls, mainly as a result of poor drainage. 4. Vertical weight. This is the combined weight of the wall structure and the soil mass above the heel. This force is essential for providing resisting moments. 5. Seismic forces. These are forces induced as a result of the earthquake which create additional dynamic force on the wall. This is a critical check in high seismic zones. We've discussed the forces acting on a retaining wall. Let's see the failure mechanism of the retaining wall as a result of these forces. A retaining wall must be checked for stability against three primary failure mechanisms. They are: 1. Overturning. This occurs when the overturning or destabilizing moment, created by active earth pressure and hydrostatic pressure, is greater than the resisting or stabilizing moment that comes from the wall's vertical weight. In such a case, the wall rotates about its toe and tips forward. 2. Sliding. This is a horizontal failure, which occurs when the soil pressure behind the wall is greater than the frictional resistance and the passive resistance at the foundation base, causing the wall to slide horizontally forward. 3. Bearing capacity failure. This is a foundation failure. It occurs when the soil beneath the base of the wall cannot safely carry the combined vertical loads on the wall, causing the foundation to sink or undergo excessive settlement. Applications of retaining walls. Retaining walls are seen everywhere in civil engineering. They are found in highway embankments and cuttings to support the edges and prevent landslides in sloped terrain. Bridge abutment. The bridge abutment is a retaining wall that provides stable support for the bridge deck and resists the soil pushing against the abutment. Basement structures. They hold back the surrounding soil, thereby creating underground space. Landscaping. Retaining walls are used to create a terrace, raise flower beds which add aesthetics to the outdoor spaces. In conclusion, we've understood what retaining walls are, their functions, types, structural consideration, and their application. Next time you see one, you need to truly appreciate the forces it bears and the implications in our daily lives. If you found this information useful, please like, share, subscribe, and turn on the notification bell for more content. Thank you for watching, and see you in the next video. Goodbye.